worked out, and that's gonna be the last thing we cover for the training module. So we're gonna park ourselves in the cam sensors, make sure it's out of gear. Here, let me fire it off. Now, interestingly enough, looking at this, the throttle angle is 0.7, 0.8. It's definitely a little bit odd. One thing I'm noticing here, look at the O2 correction. See how it was taking out 30%? And the wideband was showing 8.5 air fuel. That's actually probably why it was idling so low. It was leaning it out too much. Now, some things with this. When we have an aftermarket wideband, like I have an AM X series, it takes a little bit for the heater circuit to warm up on the wideband to broadcast an accurate output reading from the controller. That's the situation we're in. It takes about 20-30 seconds for that to come online. In that interim, where we're waiting for it to come online, it broadcasts an 8.5 air fuel output. Even though that's not accurate reading, it does that anyway. So we're in a situation where the fuel tech doesn't wait for a certain period of time. It immediately goes after whatever the O2 general is reading of a value, and it corrects that in the O2 correction. It was taking out 30%. That is not ideal. It definitely can create some problems for us. What we can do, a couple different options here. The best option I think I've came up with, and we'll talk about this, let's go here to the O2 closed loop. We could go in here and turn the closed loop. If we're at 1500 in RPM and below, we turn it off. Or even 1200 RPM and below, so it's not on at idle. That's definitely not ideal. The other option here is going in and jumping into our O2 control limits, and we can see where we're idling at, which is approximately 8.9 vacuum, PSI vacuum, which we're right about in here. And we could turn our control limits way down to something like maybe only 5%. So that way, if it's chasing a false reading, it doesn't take away the full maximum value of something like 30%. It only takes away roughly maybe 10%. Let's go and change these limits. I'm gonna change this to 10% and take this to negative 10%. So it doesn't have those extreme limits that it can correct it. Again, that was creating some problems for us when we had it running. So now what we can see here is we're idling it pretty close to the desired target, 950, 900, 1000 RPM, and throttle blade opening, we can see that's pretty consistent. We see the ignition timing again. We'd like to see that in the positives, but I can't reduce that throttle angle anymore. I don't believe I have a vacuum leak somewhere on the car, but and taking a look at that, the fan may have came on. I believe the fan actually turned on. We can see that it kicks on at 190. That was right there at 190, so I think the fan actually kicked on, which, if we take a look here, we do have the option under our thermofan load compensation. If we click enable, we can kick our throttle blade opening maybe 0.5%, and that could fix that problem that we have with the fan kicking on. And if we have any load offset, I think that the reason why that happened is because our fan kicked on. I don't have confirmation of that, but based on our programming here, taking a look at our thermofan, 190 is yet when it kicks on. So it turned on at 190, and then obviously right here it's turned off, it's cooled down enough in the coolant temperature. So it'll kick up the throttle blade opening just a little bit so it doesn't have that kind of bogging that just happened right there. All right, just one little detail I noticed. All right, now that we have everything sorted out, and hopefully we can correct for that false reading on post-start when the sensor is warming up and not allowing it to take out that massive amount of fuel, let's talk about now our intake cam position. What we're gonna do is jump in, let's go to the other functions, let's go down here under our variable camshaft sensors. First thing I want to do here is go to the wheel decoder. It's going to say, warning, VVT solenoids are disabled while the decoder window is open. Even though it says that the VVT solenoids are disabled, I manually go and always zero those out in the control because I've had weird problems when trying to do this cam teeth table wheel decoder option. Let's click OK and allow it run. It's going to go ahead and source some different values here. We're just going to click save, and it's going to establish our sensor position angle at 232 degrees. Now, what we need to do is actually upload this to the fuel tech and then fire it off and then verify our intake cam position is tracking 0. So if we've commanded the target at 0, which we have it at 0 in the table, the whole table 0, the cam position should represent that if we have no feedback or output from the duty cycle control. So we should see that we want to zero this out again so we know the true neutral position of the intake cam movement so that when we're commanding a cam target to actually rotate the cam, it's tracking that properly. Without this calibrated, your variable cam control will not work properly on a K-Series or any engine you're trying to control with the fuel tech. So we need to go ahead and let's save this real quick. Let me go ahead and turn it off. Let's power cycle it real quick. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.